Hello, my name is Mykola Haltiuk and I am a PhD student at AGH University of Krakow, and today I'll be presenting the work we've done to support the Ukrainian NLP community in its shared goal of making Ukrainian a high-resource language. This work was made possible through the support of AGH University of Krakow and the Research University Initiative. We're also grateful to Pelgrid and Cifronet for providing the computational resources we needed. Historically, Ukrainian has been considered a low-resource language, lacking annotated and unannotated datasets, tools, and models. Fortunately, this is beginning to change. Back in 2020, Pratik Joshi and colleagues proposed a 6-tier taxonomy for classifying languages by resource availability. At the time, Ukrainian was placed in the 3rd tier, the rising stars, alongside 28 other languages. By comparison, we have at the 4th tier, the underdogs. It's 18 languages such as Hungarian, Dutch, and Korean, while the top tier, the winners, so the 5th tier, featured just 7 languages, including English, German, Japanese, Spanish, and similar. Over the past years, the situation slightly changed. Ukrainian has made significant progress, especially in terms of raw unannotated data. And thanks to the large multilingual corpora derived from Common Crawl, Internet Archive, and similar sources, Ukrainian now ranks around 21st, 24th, depending on the corpus, in terms of total token count. And based on this, Ukrainian would likely now be categorized as an underdog, so 1 tier higher. And why is the volume of unlabeled data so important? Well, in the past year, we witnessed an unprecedented wave of sovereign LLMs being released. There are already efforts underway to train a Ukrainian-specific LLM. All such projects rely on 3 key pillars. So we have pre-training data, instruction data, and preference data. And while we stay back from the other 2, the pre-training data, the quality and the quantity of it is critical. And a great example of such a sovereign LLM is Belid, actually presented here on NVIDIA presentation. And Belid is a Polish LLM developed entirely by volunteers, and despite being quite a small model, so there are multiple versions of it, both under 10 or 11 billion parameters, it still significantly outperforms its multilingual counterparts, even those that are 10 times bigger. And this success was made possible in part by the massive data collection efforts of the Speedlish initiative. And it was originally launched to improve Polish representation in multilingual models, and it has evolved into the largest Polish language corpus, now containing nearly 1 billion documents, so quite a lot. It also introduced different tools, for example, for assessing data quality across documents, and inspired by this effort, we set out to build a similarly large and unified corpus for Ukrainian. Kobza, an instrument to amplify Ukrainian culture and language. So Kobza is basically a compilation of different corpora with additional processing, and it consolidates multiple corpora in one single resource. So it is very easy available and accessible. And for multilingual web sources, we include 3 of the largest datasets: Corpora X, HPLT 2.0, and FineWeb version 2. Additionally, we include Ukrainian news corpus, which is like over 20 million documents scraped from news agencies and Telegram channels. And it basically comes in the form of HTML documents, so we process them with Trafilatura to extract only the content and the text itself. And we also include UberText 2.0 developed by Dmytro Champlinsky, and this corpus aggregates a wide range of content from Telegram to court rulings and Wikipedia, and uses custom scraping pipelines to actually get those. What about Maluk? We all know that it was previously like the largest Ukrainian-only corpus available, and we do not include it directly, but it is overall included because Malut is itself a compilation. We have UberText 2.0 and Ukrainian news directly included, and the third part of Malut, basically Oscar, is a part of Kultura. So basically the whole Malut is incorporated in our corpus. And to assure the corpus quality, we perform deduplication in 2 stages. This is a computationally heavy task, especially when working on the whole corpus at once. And most projects, for example, Kulturates, deduplicate within each common crawl. But since we include some broader sources, we had to take another approach. So first we deduplicate it by metadata to reduce the volume of the documents before expensive min-hash operations. And since multiple sources reuse common crawl and internet archive, that's basically web sources, the same news articles, for example, can appear in both Kultura ads and FineWeb2, potentially even with slight differences due to different preprocessing pipelines. So for example, here we have the first 2 examples where we have exactly the same news article, but we have slightly different preprocessing, so more boilerplate was removed from FineWeb2. But as we notice, the metadata stays the same since they come from exactly the same common crawl dump, which has exactly the same metadata. So actually utilizing this, we can try to remove already a quite fair share of duplicates. We validate whether it is a correct approach, and we do not remove some extra documents, and we found that an average longest common subsequence similarity is around 93%. So we stick with this method, but still it doesn't catch everything. Some duplicates persist due to prior deduplication stages in our source corpora, which may have left a different copy of the same document. So if we have 2 the same articles come from different websites, one corpus may have left the first one corpus another one left the second one, and they have different metadata, so we won't catch it. So after this, we apply a very common min-hash locality sensitivity hashing deduplication, which is really expensive but works really great. We set a similarity threshold of 70% and use the the algorithm implemented in Apache Spark. So after both stages, we remove over 41% of all documents as duplicates. In the final version, most sources shrank considerably, and the dataset, the combined dataset, still includes almost 60 billion tokens across 97 million documents. We tokenize the data using the second LiBERTa tokenizer, optimized for Ukrainian with 64,000 vocabulary size. So using other tokenizers, for example, like the ones for Gamma or Llama, would likely result in a higher token count. And in Parquet format with snappy compression, it occupies around 474 gigabytes of space. Also, we investigate the length distribution in our corpus, and the median median length is around 350 tokens. However, for language modeling, the distribution of tokens in the long documents is more telling. So we plot a cumulative token distribution, and it basically shows that for 50% of all tokens that come from documents, 50% of all tokens come from documents that are at least 1,156 tokens long, and remarkably 5% of all tokens, so nearly 3 billion, are in documents exceeding 16,000 tokens. So this is very promising for long context modeling. Our second major contribution is Modern-LiBERTa, a continually pre-trained version of Modern-BERT trained on a 160 billion token mixture of Ukrainian and English, and we use the same LiBERTa version 2 tokenizer, which supports both language effectively and maintains a favorable token to word ratio. So the training took place in 2 stages. The first stage covered 140 billion tokens with the context size of 1024. We then extended the context to 8192 for the final 20 billion tokens. And the full training ran for 7 days on 16 GH200 GPUs on the Cephronet Helios cluster. And because Modern-LiBERTa and LiBERTa version 2 share a tokenizer, we can directly compare their perplexity and MLM accuracy. We evaluated on universal dependencies, pvouter, UA, JC, and Wikipedia, and Modern-LiBERTa consistently outperforms its predecessor. As for the benchmarks, the downstream tasks, it achieves either state-of-the-art or highly competitive results across the board, with one exception, NER UK 2.0, and we have still to investigate it, what is the reason behind it. Both the Kobza corpus and Modern-LiBERTa are publicly available. All the source code is in the UNLP repository on GitHub. Kobza is hosted on Hugging Face with metadata such as timestamp, URL, source, and subsource. And the highly compressed version takes around 150 gigabytes. And Modern-LiBERTa is also available on Hugging Face and released under a permissive license that allows commercial use. Thank you.